Bring the table down.
But since we have so much mass, that's a place where most stars fall, right?
I think college classes are going to be a lot different than high school classes difficulty-wise because it's just so much more pressure put on you. You know, you're advancing up, classes get a lot harder. In college, it's probably going to jump a little bit more.
For the first couple of years, the workloads are not too totally different. The 100 level, 200 level classes aren't that bad.
A difference is it's usually a lot more people and you have to get used to that crowd and kind of drown them out so you can take the information and soak it up.
When we talk about the hotter stars being bluer, we're talking about the continuum spectrum, all right? The black body part of the spectrum. Superimposed on that spectrum, we have the spectral lines. In fact,
I think a typical college class would mostly be less interaction of the students. They're more there taking notes, listening to the teacher, what they have to say.
Yeah, the first college was what I expected. You know, the entire, having a lot of classes, with big lecture halls and all that kind of stuff. Exactly what you see in the movies, pretty much, minus the people calling on you.
There's a lot less time for help from the professor unless you specially ask for it.
The first year you really get to know your TAs a lot better than your professors, but it quickly moves into being a lot more personable and you have a lot more personal interaction with the profs and you learn at a much faster rate, but you also get a lot more personalized attention, so it's worth it.
We're going to have a lot more serious attitude because we're going to be applying this a lot more into the things that we do.
They're due today?
No, they're due tomorrow. Thursday.
I don't know, when are they due?
Thursday.
Everything's due on Thursday, because Michael said so.
High school it depends on your high school, but it does prepare you for the workload that you'll get in college. And you'll take about 5 or 6 courses like you do in high school. And even though they'll spread out across the week instead of every day, it's still the same amount of work.
Which star is it? Which star is it? So, Nicole, which star is moving fastest towards us?
E.
E. Good job.
It's not, you know, the professor calling on a whole bunch of people, because the professor doesn't know anybody in a class of 150 or whatnot. Sometimes they'll pause and ask questions.
how would we find this out? Well, we do know the temperature. How do we know the temperature? From the spectra, right?
It's probably very, very different from the high school atmosphere, I think.
How do you communicate over cell phone? Where after you talk into that thing, where do you think it goes after it goes to the cell phone tower?
After it goes to the tower, it goes to the router, and then transfers to the wires to the next person's.
Wires to
The next hub, which transmits it.
what if it's far away hub? What would it go? Would it go wires?
It goes to wires.
Oh, passe, man, passe.
Fiber optics.
Fiber optics. Fiber optics. Yes, yes.
And then how does the information get from the retina up to your brain? What's the little cord that connects your back of your eye to your brain called? The extension cord? The cord? Nobody knows? Starts with an O?
Physics is probably not my forte, but I enjoyed it because it's interesting what you learn, and the people who teach you are actually, they're not these old guys who sit around doing experiments. They actually go out there and have fun and teach you things.
If you ever wanted to make an optical computer, how many people would want to make an optical computer? You fools. Electronic computers work much faster. You don't want an optical computer. They tried that in the 90s. We tried that in the 90s, I should say. It doesn't work. But it would be cool to do it, though.
And I say I have angle alpha, beta, gamma. What's the sum of those angles? What's that? Yeah. Pi. But wait, only if that's on a flat board, right? If I take that and I curve it on the surface of a balloon, what happens then? Yeah, that's right. That's exactly right. It's great.
After you start interacting with professors, it's a whole lot different than I thought it would be, because the professors will really talk to you and you can sit down and have conversations with them. Or undergraduate students do a lot of the real science that goes on. You can actually get your name in papers and stuff like that as an undergraduate. I have fun telling people that I am a rocket scientist when anybody's like, it's not rocket science. And of course you tell them you don't understand it and everybody laughs at you, but.
I did not know you could be a rocket scientist as an undergraduate in college. I always thought it was you get your degree and then you start studying for that career.
MOSES is the multi-order solar EUV spectrograph. Basically, it's a sounding rocket payload which looks at the sun in 3 spectral orders, which basically means that we're collecting both spatial information, where things are on the sun, and spectral information, like what the wavelengths are and what atoms are giving them off, et cetera, at the same time, which has never been done before.
But we see the sun in UV and we can see different features that we wouldn't see with a visible light camera. And that's an advantage in itself, because when we see it in 3 different ways, we can extrapolate things in a 3D image and not just see it flat and guess that this part is raised and this part is to the side and such as that. A big part of why there are so many satellites watching the sun, including MOSES, is to try to predict what's going on in the sun, why things are caused, why things go in certain directions, and plus to view things that we've never seen on Earth. You don't see things on Earth that we see on the sun. It's a completely different place, obviously, and we like to learn about different things.
Yeah, the thing about MOSES that is actually really impressive is the fact that the majority, like 90% or so of the materials on the MOSES rocket are made by students here at MSU. So that's everywhere from designing, coming up with the ideas and then fabricating it in our machine shop.
I am surprised to learn that there are undergraduates who work on that. I don't know, I guess I probably shouldn't be so surprised, but it's definitely possible. I don't know. Undergraduates have just such a reputation, which isn't very fair to the rest of them.
You find what you like. That's the whole point in going to school and going to college, is getting good at what you like and doing it.
All right, well, basically the clean room is this chamber enclosed by plastic sheeting that have air blowing down, which causes not much dust to rise up and keeps it really clean.
Everything has to be covered. You can't have hair sticking out. You can't have your fingers exposed. If there's a hole in your glove, you have to replace your glove, because any oil, any dust, anything can ruin the electronics and the optics of MOSES. What I do with the MOSES project is I work with the mirror itself. What I do is I check the quality of the mount that it's in. When we flew it the first time, it came out with some amazing images and we got some really good data from it, but it appeared that on parts of the mirror it was slightly out of focus. The mirror itself is actually curved. It's a spherical mirror.
I wanted to pass this demonstration around. I hope you all get a chance to look at this. This is a concave mirror, okay? And now, if you notice in the problem that we just solved, we had 2 different kinds of images that could form. One was a real image, okay, and one was a virtual image.
We were concerned that the mount was bending it in some way because we wanted it secure so it wouldn't jump out of its thing on its way in the rocket. So we made it really secure, but we're afraid maybe we made it too secure. So what I do is I use an instrument called an interferometer, and I use a reference mirror, which we know is a near perfect sphere. There's no such thing as a perfect sphere, but it's as close as we can get it. And I use that mirror and the Moses mirror, and I see how well it compares using fringes.
Another wavefront that pops up, and it goes out here, and what is he going to see? Fringes. Okay. Now that fringe pattern that he saw.
The first thing I do is align the interferometer, and that's a perfect lens with a laser and a cube beam splitter, which basically all it does is it takes light, half of it goes right through it, and the other half goes off to the side so I can look at it. Currently, I'm still making my interferometer work because when I use the interferometer, I have to see how well it works before I can actually work it on a Moses, and I'm not quite to that point yet.
I hear the term rocket scientist, and I usually think of somebody that's doing a lot of experiments and trying to figure out more about science, or maybe they're working with NASA. They're probably very, very cool scientists that are working hard.
Yeah, I guess I am a rocket scientist. And no, I'm not a super genius. And yes, it's fun. But yeah.
One of the graduate students in our lab has this nice little trucker's hat that says, "Actually, I am a rocket scientist." So it's pretty entertaining. I'd say come to college no matter what. I mean, it's a worthwhile experience, and any type of bachelor's degree will increase your earning power by about 100%. And physics, we would like more people in physics, but a lot of people just don't know or aren't sure of it. We have a lot of transfers from different departments. And you can always come in as an undeclared major for a year. Take some of the physics courses. There's some really fun ones at the beginning. But if you're in physics and you decide you don't want to be in it, you can always switch to something else. You meet a lot of people, and people switch back and forth for the first couple of years before they find what they're happy with. And not everybody's going to be happy with what they're doing. Come to college first. Don't be just dead set on something. Figure out if you really like it first, because you're probably going to be doing that for the rest of your life, and you want to make sure you enjoy it.